So as mentioned, I'm Kendall, and this is Henry, and we're at IOST. So today we're going to talk about the motivation for our app framework that we developed at IOST, the React Django architecture, and we'll have a brief demo at the end. And so IOST is a artificial intelligence company developing software for enterprise, and we have an enterprise software platform which we provide for healthcare, finance, and government customers. And so the motivation behind the app framework we developed we call Envision, was to empower data scientists to build apps quickly. So we want to enable them to build proof of concepts for our customers, as well as to provide the data scientists working at our customers' companies to also prototype and deploy apps quickly using our platform. And also we wanted to build many reusable components as well. So as you can see, here is a demo of an app made using Envision on the right. And so why did we decide to go with Django? There's a great open source community, as you all know. Also, data scientists like to use Python. So this is a huge benefit because they have experience with the libraries like scikit-learn, NumPy, pandas. And so it's more familiar for them. We also have support of Websockets using Django Channels, which I'll talk about a bit later. Django provides form validation. So since we have to take some sort of input into our application, being able to do the form validation on the back end is very helpful. Also, there's a nice abstraction over the database in Django Models. And also, there's so many third-party modules as well. And now Henry will talk about React.
Thanks, Kendall. OK, so I'm sure a lot of people are wondering here, you're developing an app framework. Isn't Django an app framework? Why wouldn't you just use views? Like, why bring this complicated React thing into the mix? And there are a lot of reasons why we decided to go down this route. So first of all, when thinking about using client-side logic, we realized that it would be a lot more flexible than using server-side templating and rendering. And when we kind of started thinking down that route, we realized that React was really the best option to go with. Some of you may know it as kind of the JavaScript framework flavor of the month right now, but it actually has a lot of staying power. And it's proven that it's very powerful through its use of the virtual DOM. So for those of you who don't know about what the virtual DOM is, at a high level, basically, React's internals allow it to efficiently re-render content so that when it's updating the page with new data, it does so in basically a very efficient manner instead of reconstructing the entire page. In addition, there are tons of libraries and tools that are super useful for us. So one of them that you may know is Redux, which is basically a state management library for React. And there's also some React router stuff and ways to make WebSockets calls, which is really the meat of this talk that we're going to get into pretty soon. So our last reason was when we were developing an app framework, we were thinking, OK, we want our data scientists to be able to use these Python components and write out things like a page or a form or a chart. And actually, the way that React is constructed, for those of you who don't know, it's basically these JavaScript components. So it very closely mirrors Python classes so that when we communicate and serialize that data, it matches really well to the front end that we designed. So now we're going to talk about WebSockets, which is basically the glue between these two worlds. So let's just get a show of hands out here. How many people know about WebSockets or have worked with WebSockets before? OK, a lot of people actually. That's really awesome. So for people who don't know, I'll just give like a really brief explanation of what WebSockets are and why you might want to use them. So when you think about like traditional HTTP communication, it's kind of called a pull paradigm. So what I mean by that is basically you have the idea of a client and a server. The client makes requests to the server and receives a response. So imagine for a second that I'm React over here and Kendall's Django. So if I want to get some information from Django, I have to go and ask Kendall, like, hey, can I get a chart? Or, hey, can I get some data?
Sure, here's some data.
And yeah, so Kendall can send me a response. Now, if Kendall wants to talk to me, I don't really care. I'm not going to listen. So yeah, it's not very friendly. And it's not very efficient because every time that we want to talk, we have to open a socket communication. Websockets, on the other hand, allows for a push paradigm and a persistent connection. So basically how that works is we first have our little handshake upgrade. So we start with HTTP. So I'm like, hey, Kendall, do you want to use WebSockets instead? Like, this really sucks. Sure. OK, cool. So now we're using WebSockets. And now what this means is I can send Kendall messages, and Kendall can send me messages whenever he wants. So you can do really cool stuff with WebSockets where the server can actually push messages to a number of clients. And this is called broadcasting. So you no longer have to operate on this model of making a request, waiting around for a response. Now the server can send information to clients whenever it's ready. And we wanted to utilize this for the asynchronous loading of big data. So for Envision, I mean, you can imagine data scientists working with pandas and NumPy and these huge data sets. It's going to take a while to process things on our Python backend. So we want to basically push that data to the front end as soon as it's ready. In addition, we realized we could use this for notifications, progress messages, loading spinners, basically a bunch of different use cases for keeping the front end very responsive and interactive, so you're not just waiting around for data to load. And now Kendall's going to go ahead and talk about Django Channels, which is how we basically bring this architecture to life.
Cool. So here's a diagram of the channels architecture. As you can see on the top, there's the web browser, and on these blue lines on the left are the HTTP messages, and on the right you can see WebSockets. There's this interface server which handles the basically ASGI and WSGI communications, which connect to Django and Django channels. And then there's this channel layer, which kind of routes the messages to the consumer. So you can see the consumers here. There's the HTTP consumer, which can route messages to your standard Django view functions. And in addition to this, you can see the WebSockets consumers on the bottom for WebSockets messages. And here on the right, you can see background processes as well. So this is one of the other nice features that we have with Django Channels is you can actually have the background processes send messages back up to the client. So in our case, for example, if you're using a background worker like Celery, you can have Celery worker send updates all the way and push notifications up to your client when a long-running machine learning model is done training, for example. And so the libraries that we're using here are include Django Channels for the channel layer and consumers, and also Daphne, which is a package developed along with Django Channels 2 for the interface server. So the interface server is Daphne. And on the back end, optionally, if you like, you can run Celery as well. And so let's see. And Henry will now talk about the front-end architecture.
Cool. All right, so we're back to more front-end stuff. I'm just going to give you the warning that we might get a little in-depth with some React Redux stuff. So if you're not familiar, don't worry. There's like a ton of boilerplate, but we'll try and stick to just the core logic here. So before we dive into that, we want to talk a little bit about the object model that we designed for this application. So maybe think to yourself really quickly, if you're writing a framework for people to write web apps in Python, what kinds of things do you need to have? What kind of things do you need to expose to them? And for us, we are thinking of these things that you see in this hierarchy model here. So first of all, you have the concept of an application. I mean, this is really basic. This is your overall app. Maybe it just has some configuration and a theme. And within an application, you might have a navigation or tabs, ways to move around the app and visit different pages. So in our world, the page is like the most important object. This is what data analysts and data scientists write in our application. They write pages. And within pages, they use forms, which are very familiar to Django users. Forms have fields. They can be submitted. They can be validated. They're very useful for interacting. And you have blocks, which are like charts, tables, anything that you want to display to users. So with this combination of objects, you can present data, you can get user feedback, basically everything that you would need in a simple web application that displays some information. So we use this object model both on the Python side and on the React side. It can be kind of annoying because sometimes, if you create a new component, you have to create both a Python component and a React component. But as I mentioned earlier, they are very similar, so it's a pretty easy process to have them available on both sides. Now, when we're actually rendering things on the front end, we use, as I mentioned, React and Redux, and we use Json Rpc methods, or basically you can think of these as ways of making Websockets calls. So we're going to go ahead and take a look at some code here. So we have this demo repo, and we'll show you the demo at the end, but basically we'll start with a really simple example of how this JavaScript is instantiated, and then move into how the actual flow works. So for starters, we're going to go ahead and take a look at how Django is serving up React. So if you wanted to do this yourself, it's actually pretty straightforward, and I'll show you how it's possible. So is that a good enough size for everybody? Can I get like a thumbs down if it's not? Okay, great. I see some thumbs up. So here's basically our views function. And we have one view in this application, and it's really straightforward. It's an index view. So our URL routing, is set up so that this is basically loaded every time that you hit the running Django server. So we hit the index view, right? And this is really the only line that I want you to care about here is we basically just render a template. Like that's what Django's all about, right? It's pretty straightforward. So let's go ahead and take a look at that template and see what that's doing. So if we go here into our index.html, okay, this is pretty straightforward. We have just basically a thin wrapper around base.html here. So this is really the meat of where this template lies. And here we have some meta tags and we have some configuration information. There's a few things I want to point out. First of all, we use this to load in any static files. And the static files that we're loading are our main CSS file and our index.js file. And you might be saying, yeah, this is pretty basic. This is like Django 101. But the fun thing about our Envision app is this is the only view that we have and the only set of templates that we have. So this is all the front-end logic that's done or that's handled by Django. After this, we basically pass it off to this index.js, and that handles everything else. So that will take care of routing, making calls to the backend, all the user interactions. So think of this as a very basic handoff from Django over to the React side. And this index.js here, this is our fully compiled JavaScript repository, just minified and compiled using Webpack. So all our React code is loaded up as soon as you hit the Django app. Okay. So now we're going to go ahead and do a brief explanation of how the React Redux flow works, and then we're going to tie it into how that works with Django. So once again, let's just do like a quick show of hands here. So how many people have worked with React and Redux together on the front end? Okay, so less people, but still actually a really good amount. I'm very happy about that. React's awesome. So for those of you who don't know, we'll walk through this really quickly, and maybe this will be a good refresher if for some reason you forgot how it works. But basically the main concept behind React and Redux when they're combined together is you have this thing called a store. And it's a data store. It holds your data for your application. Pretty straightforward. Now, your store contains pieces of state. And these might be like, what user you have logged in, or what page you're currently viewing. Now, that state defines the UI. So you have components that are rendered based on properties, or props, passed down through the state. So when you visit that page component, you can see, okay, now I'm going to show this page for this user with this color. The UI then triggers what we call actions. So you might do something like click a button or select a dropdown. And this might trigger a Redux action, which can basically modify some data or make an RPC call. So this right here in actions, this is where we make the call to the Django side. When we get any data back, we send that to a reducer, which basically just transforms the data and passes it back into the store. And then the magic of React and Redux is once the store is updated, it updates the state, and the UI gets the new props. So just like that, we can go from clicking a button to receiving entirely new data. And here's how that flow looks like for Envision, so a little bit more specific. So we start off with rendering our page that the user has defined. And at the start, the page might not have any information. It might be really basic. But then once you click a button or trigger some request, we kick off that WebSocket call, and we call it getPage in this case. This call goes to the backend and hits a Django consumer, which is basically a listener on the WebSocket channel. And that's called getPage as well. So that's how these two relate to each other. Django does its magic and will process some data, maybe use some Python libraries to do some cool stuff there. And we return that data and send it to our getPage action. This basically goes and tells our reducer to take that data we got from the Django side and add it to the new state. Then the components are automatically re-rendered for us, and the page now has some new data. So this is a pretty standard flow, and all we've really added is this piece here, where we send a little message to the Django backend. And so now we're going to go ahead and do another brief code example of what this looks like on the JavaScript side. So again, I apologize if you're not interested in seeing any JavaScript. You're going to have to sit through a little, but it's pretty cool, I swear. So if we go into our app here, here's our app component. And again, we can excuse all the React boilerplate. I'll just highlight the parts that I think are interesting. So in our render method, this basically tells us, what kind of HTML content are we going to put on the page. And these are the properties that we're receiving from the backend. So here's some really interesting ones. Socket and socket node are basically components that instantiate the WebSocket connection. So they make that handshake that I was doing with Kendall earlier in order to upgrade the HTTP connection to a WebSockets connection. This next piece of state here is called page loaded, which is basically a Boolean. It tells us if the page is loaded or if it's currently loading. And lastly, we have our page data, which is a dictionary, which basically has all the stuff that we want to display. So that's the information we get from the state. And then we can go through down here and say, maybe we'll make some title text, and we could maybe add some images to the page, but only if we have page data. So if we don't have any page data here, we're just going to skip this section entirely. Now, when we get down to rendering the actual HTML content, this here is pretty important. So this is where that socket component actually instantiates the connection. So as soon as you hit the page, it's going to go ahead and do its job to connect us to the Django server with a WebSockets connection. Once that connection has been established, we can come down here into this block. And basically, we're just going to render, a little header tag, a little button, maybe another little button, and they're going to have some on-click handlers. Now, when we click these buttons, we're going to dispatch that action that we talked about. So I can just really quickly go ahead and show you what that looks like on the JavaScript side. We go back to our app container here, and this is what contains the business logic. And here we have the function called by the buttons. So when you click a button, it's going to call load page. The first thing that it's going to do is send a message to our, or it's going to send an action, which is going to basically tell us, hey, let's set that page loaded to false. The page is no longer loaded. Don't display anything. And then it's going to go ahead and dispatch a socket message. So this is the WebSockets call here. It's going to dispatch a message called getPage, and it's going to pass along a page ID. Pretty straightforward. Once it receives the response from the Django consumer, then we'll go ahead and dispatch an action to set that data in the state and reload the page. So when we do the demo in a second, you'll see this happens incredibly fast, but this is the entire round trip that's happening in order to basically render some information from Django in React. And now Kendall is going to go ahead, I believe, and talk about how this looks like on the Django side, so what actually a Django consumer does.
Well, thanks, Henry. So we have this protocol called Json Rpc. And so Json Rpc lets us have a nice interface for sending and receiving messages. And what it provides us is an example like this. You have an ID tag, which lets the client, the web browser, set an ID for which when you send a message, then the response you get back should have the same ID. So if you send a bunch of messages, this helps you organize the responses. The JSON RPC is the version, and you can look online to see the difference between the different versions. And here we're using 2.0. The method is the name of the Python method, which we're going to call in the backend, and the parameters are the page ID. And so we're using this nice library called Django Channels JSON RPC, which is, and we're subclassing from the Django Channels Websockets consumer. So this is the main consumer, which I showed in the block diagram above, previous slide. And the Django consumer will then return the JSON response. And so here's our actual getPage method. As you can see here, we have subclassed from the JSON RPC consumer and made a demo RPC consumer. And so all you have to do is create a decorator at .rpc method and then define your WebSockets consumer method. So basically here we define getPage. It takes in the page ID and it returns a dictionary of the information you need to render a page on the front end. And so now Henry will show a quick demo of the WebSockets.
All right, so we're going to do a live demo, so bear with me. Hopefully everything works. Okay, so the page is loaded. This is good. So what I'm going to do while I have this up here, y'all can see that, right? Okay, cool. So we have open here basically the developer tools console. And the reason why this is open, actually, sorry, that's, oops, let me get a tiny bit smaller. There, is that still all right? Okay, just so that we can click through it. So basically what we're going to do here is show the actual WebSockets calls that happen while this application is running. So you can do this yourself. This is available to you. It's a handy little tool, and if you're writing any WebSocket applications, it's incredibly useful to see the responses you're getting. So when you open your developer tools in Chrome, it's in the network tab under WS here, WebSockets. So first things first, when I went ahead and loaded the page, we already got something in here. So let's go ahead and investigate this and see what this is. So this WebSocket message is actually, we have here a 101 switching protocols. So this is that handshake upgrade that I was talking about. As soon as we load the page and enter the application, we switch over from HTTP and open that persistent WebSocket connection. And here you can see that indeed we're connected to Daphne, the server, so everything is working as intended. So now what we're going to do is go ahead and click a button and start that flow that I was talking about earlier. So just again, what's going to happen is I'm going to click the button. We actually have a time sleep on it, but it's still really fast, so it'll be pretty quickly, like blink if you miss it. But basically, when you click on this button, we're going to go ahead, set the page to loading, go get some data from the Django consumer, and return it to the front end and render it. So bam, we got some company logos. And if you look here, we got some WebSockets information. So we can go ahead and inspect that. So here, sure enough, this is our getPage WebSocket method that was sent out. You can see like the JSON RPC number, the method name, and sure enough, we sent over the page ID. And then if we actually go to the terminal, we have printing in the consumer getPage. So indeed, our Django consumer picked up the message, did some processing, and returned us some image links and a title to display. And you can see that here in the response. So if we look at the result, bam, there's the images and the page name. And this actually, it works on the other page too. So we can kind of go ahead and toggle between pages. And this is like the basic functioning of a standard WebSockets loop. Now, you're probably wondering, isn't this like extremely basic? Like, couldn't we just do this with HTTP and views? Like, why do we need WebSockets to load images? You know, I can do that in my sleep. So if you thought that, you wouldn't be wrong, because, yeah, this is a pretty basic example. But as we'll explain as we go on, where WebSockets really shines is in those other kind of interactions where the server can actually push data when it's ready to the front end. So here we're kind of doing a standard request response. But for example, because we have that persistent connection open, we could actually send the request to the server, and the server could go do whatever it wants for 10 minutes and push a response when it's ready. And the front end doesn't have to sit there polling for it. But we'll get into more of that in a little bit. So now Kendall's going to walk us through how state management works in our Envision app.
So here's the diagram we had again. With Envision, we have a stateless API. So basically what this means is we're not storing the state in the Python code. We have the data backed up by Django Models. So basically, the nice thing about this, having a separate data store, for example, Postgres, is that we can allow the view function, the WebSocket consumer, and any other background processes to talk to the same database and share data through the database. And also, as Henry mentioned, we store minimal state on the front end as well and re-render when we have a new information on the page. The other nice thing about having state on having the background processes is basically we can send notifications up after running a long task as well. And also another place where we're storing, another database that we're using is Redis. And so the channel layer is actually backed by Redis data store, basically. So it manages the recipients. So when you have the channel layer, you want to know who you're sending the messages to. So this channel layer allows us to broadcast the messages to multiple web browsers, for example, if you're connected to the same page and they all want to be updated at the same time. So now Henry will talk about some of the challenges that we faced in developing Envision.
Alrighty, so this is what I was alluding to earlier. This is asynchronous loading of charts, tables, and other big data. So in the example that I gave and in our first draft of Envision, our WebSockets calls basically rebuilt the entire page. And the reason why that was happening is we had a page object written in Python, and we sent a WebSockets call, getPage, to go get that information. We then serialize that page and send the entire thing up. And while that works great for really small pages, you can imagine that that might be really painful if the content that you want to display on the page is extremely large or might take some additional processing based on the request that came in. So it took us a while, but we thought about some interesting ways around this, and this is really where we decided to take advantage of WebSockets. So we created this publish-subscribe model, and I have subscribe in quotes because we took inspiration from this kind of model, but it's not actually how it's working, where there's no polling or subscriptions going on. Instead, what we do is when we send that data to the front end for the first time, we might send up, say, a pie chart, and it has no data associated with it originally, but we can define a data source, which is basically like a key. So let's say we send up a pie chart, and it has this data source key, pi. So when we load up the page, we might have some content that is displayed, like a title or some fields. And instead of trying to wait and display this pie chart when it's finished loading or processing, we can just display a blank box or maybe a loading spinner, something that indicates that the chart is yet to come. And then what we can do is we can actually manage that processing asynchronously on the Django side. So this is where we can use sub-processes, workers, additional threads, or even something like Celery to basically handle some additional processing, and maybe it'll take a really large data set and condense it down, use a library like Plotly to create this beautiful chart, and then serialize it and send it up when it's ready. And the way that it's going to send it back up is through a different RPC method we created called refresh widget. So this call is kind of the inverse of what I was demoing earlier, where the server is just sending a message to the front end without any previous request. This wouldn't be possible in HTTP. So the server, whenever it's finished, can just send up this serialized chart information along with that key, pi, that we mentioned earlier. And the front end will receive this data and can basically go through the DOM, find the element that was rendered with that data source key, and repopulate it with this data. So you can have a case where you see some of the page loaded instantly, and then other pieces come in over time as processing is finished. This is incredibly useful for the kind of work that we do. The software that IASD is built on involves a lot of machine learning algorithms that can take hours or sometimes days to run when we're talking about data sets that are 1 million columns by 1 million rows. So it was essential for us to be able to have this asynchronous loading, and it could really only be accomplished with WebSockets. Okay, so do you think we have time to do a quick demo of what the actual application looks like? Kendall's going to go ahead and show that to you.
Cool. Thanks, Henry. Sure. So here's a demo of our app at IASD. Here you can see on the top we have the application, which is in this case sample app. We have this navigation bar. It's a step-based workflow. So we're just showing, for example, a fields page, a blocks page, and containers page, and then mixed fields and blocks. And so I can type in something here, Kendall, and then fill out a form. I can upload a file. And this is basically the React version of a Django form that we would instantiate on the back end, basically. And then we click OK. And then you can see some progress being sent up. And then loading the next page. And here you can see an example of some of the other components for which Henry described, basically. For each of these components, for example, a table, another table, an image, Markdown, we have both a Python component and then a React component. So the difficult part is the first time is we have to develop this pair of components. So it's a bit extra work. But then in the end, the result is that the data scientist who wants to instantiate these just needs to write some Python code to instantiate a React chart. So this is really powerful because then the data scientist doesn't need to know JavaScript to develop these components. And here's an example of some other charts that we can show. And some containers, so we can have different styling of the containers as well, and showing hiding enabled through. So in a lot of cases, to enable these, we have to provide extra parameters in our Python objects. So if we want this container to be able to show and hide this container, we have to have a parameter which lets you set this configuration on the front end as well. And then on the last page, let's see, mixed fields. You can see here's an example where we can intermix like both the Django form field as well as some images and tables. So I think that's it for the demo. Yeah, do you guys have any questions on the demo or the? Yes.
With connections dropping, or like a WebSocket, I don't know, the connection being dropped and the client like waiting for a response that never got here, or what if the client would like close the tab after, or something like that? No?
Yeah. So yeah, this happens. So the question is, what do we do when a WebSockets drops? So yeah, a lot of times like you have to sometimes refresh the page, and so then it'll reinstantiate the WebSockets connection. But then the nice thing is, since we're database backed, if you go to the page, okay, so Henry mentioned this previously, but we're using React to route for the URLs. So this actually, we're still loading the index.js here, but you can see the URL is objective/14. So this will tell React, okay, we need to get this objective and maybe this page number 14. So then if you refresh your browser, then you can go back to the same page because you're fetching the data for the page from the database, and you know which page you're on, basically.
Hello. Are there any special considerations regarding authentication and session that comes into play with channels?
Yeah, so there's there's a lot. It's a really, really complicated topic, and maybe next year at DjangoCon we can talk about authentication with channels. But in brief, the one thing that you want to keep track of is basically when you create a session or get some cookies, you will want to recreate the WebSocket connection using those cookies. So that's kind of one of the issues that we've had to face is making sure that basically you instantiate the WebSocket connection. You might hit a specific endpoint or enter some data on the page, and it authenticates you and creates a Django user object. And provides a session or some cookies, basically some way to track that you're logged in. And you actually have to recreate the WebSocket connection with that and make sure that that information is passed with every request. So that is still something we're kind of building out on the Envision side. But another thing to note is that that's actually the only other place where we use a Django endpoint. So I lied earlier when I said that that was the only view. We actually have one more, which is for logging in, because that's another thing that Django provides us that's great is the user system and authentication. And so we actually use a standard HTTP authentication endpoint for Django. And then once that is established, we recreate the WebSocket connection and make sure that those cookies, so that a trace of that authenticated user is present in every single call.
I'm kind of curious how you deal with load balancing in a situation. Let's say you've got two clients that are accessing the same server, and all of a sudden one client starts up a task that's going to be like really demanding on the server. Now the other guy is going to be waiting, and I don't know how you can dynamically load balance basically in a channel type environment.
Yeah, so for load balancing, as far as the tasks, the tasks between the front-end browsers and the Django app should be pretty light. We have a separate API, a separate machine learning platform where most of the big data processing happens, like in Hadoop. So this is kind of asynchronous. This is why it's nice to have WebSockets, because we can have, like, for example, a celery worker waiting on a big task, and then when the task is done and so there's an HTTP API, so maybe it's actually waiting on an HTTP response. But then when the celery worker gets the response back, it can send a WebSockets notification back to the two browsers that, okay, this long-running task is done. So we offload the work to our platform for big tasks. Yeah.
Hello. Thanks for the great talk. I really think this is really cool. My question is, for all these data components, are they served, the markup and the logic for that, are they served initially? Or are they served as a response to the RPC request, and somehow that component is injected into the React app?
Yeah, so it's more like the latter. Basically, as Kendall was mentioning, we use the React routers. So when you visit a page with a specific route, it makes that get page call to the backend. And essentially, if you were to break at that point in JavaScript or pause on a breakpoint, you would see a blank page. And that data, basically, you would send the request to the consumer side. It would process the data and serialize the whole page as a result. And then that's returned up to the front end and then loaded in there. So essentially, that's why we try and keep the pages as lightweight as possible, because if you were to refresh the page or hit another page, you're doing another round trip through the consumer side.
That's really cool. Thank you.
Mm-hmm. Thanks for the talk. So how do you write tests for this kind of thing?
Okay, good question. So, let's see. Okay, so for testing, we had, yeah, it is kind of tricky to test. We did a couple of things. For unit tests, we mock out the WebSockets server. So we have this mock object which mimics the server. In addition to this, we have this, we call it the driver. So a Python WebSockets client to also test out against a live like Django app, which you can test. And in addition to this, we have Selenium tests. So it is pretty complicated to test, but we are able to test using these three methods. And it is important to have a lot of testing.
Assuming with WebSocket you have a kind of a back and forth, different states carrying over between the conversations, how do you emulate those?
So the question, sorry, could you,
like
don't quite understand the question, yeah.
like for WebSocket, it's kind of a back and forth message passing. Yes. How do you emulate those back and forth, and maybe even emulate an interruption of the connection?
Yeah, so for our unit testing, we actually mock out all the calls, and we'll typically test out, for example, like one method at a time. So like using unit test principles, we can basically mock out the RPC client, and there's some boilerplate that you can look into that basically sets up a fake WebSocket connection. So you can just kind of test that indeed the right parameters are being sent over the connection. In terms of testing the full back and forth connection, that's what our Selenium tests handle. So basically, we have a bunch of sample applications that test that, okay, if I do indeed hit this page, then this thing gets called and the page gets re-rendered with this data. So we kind of, if that makes sense, yeah, we test each method individually with all the RPC stuff mocked out, and then we test the full end-to-end application using a live Selenium test. Thank you so much.
And we are now at the end. Give a round of applause.
Thank you.